Welcome. So, we will resume to the power k factorial design. Today, we will discuss a special thing, that is the issues related to coded design variable, issues of coded design variables. If you go back and see the subsequent lectures what I have delivered in last couple of classes, you have seen that I have considered two factors A and B, and I say that A has two labels, low, high. Also B has two labels, low and high, and this low we have denoted by -1, high we have denoted by +1, here also -1, here also +1, and the individual, then this is basically the settings, and then we have created design matrix with reference to suppose A, B, then we say this is -1, +1, -1, +1, then -1, -1, +1, +1, and this treatment combination we denoted like this treatments. This is your 1, this one is A, this one is B, and this one is AB. And obviously, you have created AB interaction by multiplying A column A and B, -1, -1, +1, and then you found out the y value. Actually, we have used y total, and this is also y total we have denoted like this also 1 A B A B. Here 1 A B A B, the treatment combination. Here by 1 we said the what is the total, here what is the total value, what is the total value, what is the total value. So, now see what about this A and B, they are real physical variables. For example, if I say A is, it is a chemical process, A is reactant concentration in percentage, and B is amount of catalyst, then when you actually conduct experiment, there is no -1, +1 or low and high. What is there? There are certain percentage for A. It is the designer or the analyst, the process operator who is having knowledge, he knows what is the range. And in the beginning class I said that usually maybe minimum value will be low and maximum value will be high, or some value within the operating zone will be low and high. Let this is, so in reality it may be low may be 15% for A, high may be 25%. Here low may be 1 pound and high may be 2 pound, that is the amount of catalyst. So, that means essentially if I write down this one, that means in place of A also if I write x1 and in this one as x2, then or you can write A, B, no problem. So, -1 means A is 15%, B is 1, +1 25%, this is your 1, then again 15% 2, then 25% 2. So, this is the original value, or that means original units or other way I can say these are engineering units. But when we are defining like this, we are converting this engineering unit to coded units. Minus 1 plus 1 irrespective of whether it is the what is the quantity. So, suppose for B it is 1 and 2 and A it is 15 and 25%, but here you see it has been transformed to minus 1 and plus 1 and it has become a unitless kind of thing. Okay. So, when you do the experiment, you tune the process with reference to the factors in terms of its engineering unit, which is no original unit. But when we are basically giving you the treatment matrix or design matrix, we are basically doing in terms of coded variables. The issue is that how this transformation takes place, number one. Second issue is that as we have designed, what are the advantage of using coded variable? It definitely makes our mathematics calculation simpler. Now, third one is if we do when you do regression kind of analysis and develop the response surface or the effects. So, what way the coded variable, using coded variable when the effects computed by regression and using your original units, the effect and their significance, will there be any difference? If there is a difference, why this? And finally, is there a way to, even if your analysis is done using coded design variables, can be converted to the original units or engineering units, and if there are such problems, some problems, then why should we use coded design variables? Why should not we go for only engineering variables? So, these are the issues which we will be discussing in this lecture today. Okay. So, let us see the contents I have already given you. We will give you the scheme for transformation from code, that is means original to coded and coded to original. Then we will see some regression equations, and then we will discuss the advantage disadvantage of using coded design variables, and finally, I will show an example of the for that advantage and disadvantage point of view. So, you can recollect this kind of diagram, the geometric view of the design matrix. This is for the 2 factor case, this is 3 factor case, and 2 factor case, this is minus 1 plus 1 scheme, 3 factor case, and this is that will be 3 design. These are all known to you by this time. And coded to original to coded variable and reverse one, we will discuss with reference to 2 factors, and please read this slide carefully. See, the design variables are measured in their original measurement scale, what I have already told you. If this first factor is reactant concentration, it is measured in terms of percentage, and if it is the second factor is our amount of catalyst, it is measured in terms of units like pounds. So, now coding refers to transferring the scale of measurement so that the high value becomes plus 1 and low value become minus 1. I have shown you that high or plus 1, low at minus 1. So, the transformation is basically how the 25% will be transformed to plus 1, 15% will be transformed to minus 1, and similarly here 1 pound will be transformed to minus 1 and 2 pound will be transformed to plus 1. So, in this example 2 factors A and B, and our job is that -1 correspond to 15%, +1 correspond to 25%, -1 correspond to 1 pound, +1 correspond to 2 pound for factor A and B respectively. So what we will do here? So we'll start with one factor only for example, although we are explaining two factor case, but we will do it separately for each factor at a time. Let the original value be x. Otherwise, I can say x is the variable. Now, suppose the high value is, let it be, we are writing xh, and low value we are writing as x low. So, create two quantity alpha, which is xh plus x low by 2, and beta, which is xh minus x low by 2. Okay. Now, if x is measured in original unit, then the coded unit x coded can be x minus alpha by beta. Okay. For example, if we want that 25% to +1 and 15% to -1, because our xh is 25% and x low is 15%, then alpha equal to 25 plus 15 by 2, that is xh plus xl by 2. So, this is 20 or 20%, and beta will be 25 minus 15 by 2. So, this is 5%. So, if my observed x is xh, then what is the coded value? It will be xh minus alpha by beta, which is basically xh is 25%, minus alpha is 20%, beta is 5%. So, this is basically 5 by 5 equal to +1. In the same manner, this basically x coded when high. So, in the same manner, for x coded for low will be that this will be x low minus alpha by beta. So, x low is 15% minus 25% by 5%, which is basically -1. So, if you do in the same manner for the other factors, like your factor B, that is also in the same manner you will be able to do. So, let us see what we have done here. Okay, I have not, I have given here. So, for A, alpha, beta, and for x low this is -1, similarly x high it is +1. Now, it may so happen that the coded value is given. So, how do you get back the original value? You will be getting back original value from this equation. From this equation you can write x equal to beta x c plus alpha. Okay. So, let us see the example. This example you have seen earlier also. So, the advantage of using -1 +1 we are getting here. Because of this -1 and +1, I have shown you using by least square regression methods that ultimately the effects are effects you have seen that this contrast is used to compute the effects. So, we have shown you two ways of finding out the effects. One is basically from the physical meaning point of view, that means the effect of A when A at low and A at high, the average difference, that way these are the things. and this is what is the data, and you are getting like this. And what we have done, we have basically the source ANOVA table, and this table is known to you. I do not want to discuss further, and you found out that p value is not significant for AB interactions, and this is what you have done. This is just to remind you that this is the way things are done. Now, from there straightway I am going to the regression equation. So, what happened, as you know that the regression equation beta j, or other way I can in this case suppose beta 1, which will be a by 2, and beta 2 will be b by 2, and beta 1 2 will be a b by 2. So, that you have seen earlier, because regression effect talks about unit change in x, what is the change in y. H talks about when we are changing -1 to +1, what is the change in y. So, as a result, this will be a is divided by 2, similarly other effects. So, as a and b are known, and also the beta 0 will be the grand mean, So, that means from the data, that sample average. So, you get, if using this data, you will get this equation. What about x1 and x2? Because x1 x2 AB interaction is not significant. So, as a result, this equation we got from the data given in this table. So, that means the response surface what we got, this is 27.5 plus 8.33 by 2 into x1 minus 5.0 by 2 into x2, and we have not considered the AB effect, which was basically effect wise it was 1.67. So, that means plus 1.67 then x1 into x2, and as you know we are using two symbols, either A, B, C, D or x1, x2, x3 like this to represent the factors. So, they are interchange, we are writing interchangeably. So, you must keep in mind this thing. Now, this particular estimate value is not significantly different from 0. So, that is why we have not included in this in the final equation. So, your equation will be 27.5 plus 8.33 by 2 x 1 minus 5.0 by 2 x 2. Here this x 1 and x 2 they are coded. Coded means -1 and +1. This is basically the. Now, you and the regression equation here, it is with reference to the coded x 1 and x 2. You may be interested to go back to factor A and B in the original scale instead of writing the coded scale for -1 and +1. So, I told you that if you want to go back, what you require, you have to use for that particular variable original unit beta xc coded unit plus alpha, where alpha is xh plus xl by 2, beta is xh minus xl by 2. Okay. So, in this case then we will use this. So, we want in the original units, original oblique engineering units, what is the regression equation. So, regression equation y cap will be 27.5 plus 8.33 by 2 into x 1. So, what you will write in place of x 1? So, I am writing in place of x 1 a. What is basically the, how do you get, what is x c? X c we are writing x minus alpha by beta, and and what is your beta? Beta is xh minus xl by 2. So, if we write this a, this is the original value, minus alpha is 20 by beta is 5. Okay. So, this is my xc plus no minus 5.0 by 2 into this will be b minus what was the alpha value 1.5 divided by 0.5. So, what is happening here, from coded value to original values you are getting, and if you simplify this one you will get 18.33 plus 0.8333 a minus 5.00 b. Okay. So, you have coded values. Now, in the you just replace this by this, that is what I have done. So, that is the beta value, and this x1 is replaced by the original counterpart, that is x minus alpha by beta. X here I am writing a, or you can also write x1, absolutely no, that capital X1, but better write a, and here we are writing b. So, you are getting this. What is the difference between the two equations? If you want to use this equation, you have to use suppose you want to get the predict the value of y given the factors values, then the original values you have to convert to coded value and use the coded value here for x1 x2 and get this value. But here what will happen? Here what happened? You use the original values and then get the predicted value. Okay. So, this is what is our, that is what the way coded transformation and to original transformation from coded variable. And now you know that using either the coded or the original one, either this or this, you can find out the response surface. Here what happened? Response surface is a flat one. The reason is basically there is no interactions here, and the contours are parallel to each other, and how to interpret the contours I told you several times earlier. Okay. So, now you know that the transformation from original to coded, and again when you have the regression equation in coded variable, how it is to be converted to original variables, that also you know. Now, also now you know that the original regression equation with original variables can be used to develop the response surface and the contour plots, and accordingly you can interpret and use the results for the purpose it was designed, that sense. Now, I will show you some of the advantage and disadvantage of using coded variable. You see, coded design variables vary from -1 to +1 and they are dimensionless. Original design variable vary within their actual and natural ranges and different dimensions. So, that means the variability for coded variables is from -1 to +1. In between anything is possible. For example, what I have given you, that x c equal to x minus alpha by beta, and in our example for reactant concentration, this minus 20 by x minus 20 by 5. When x equal to x high, you got a 1, when x equal to x low, you got -1, but x can be in between -1 to plus anything. Suppose it is not the minimum one like this one, 15 or 25%, let x equal to 10. What will happen to coded value? That is 10 minus 20 by 5. It will become -2. Suppose no, x is 20, then coded value becomes 0. So, okay. So, but its range is always what I want to say that as this 10 is not within the range. So, this 10 is not within the range, this is not considered. We are basically considering low to high, this is the range of experimentation. So, -1. So, this we do not consider, this one we will consider. Second, so as they are dimensionless, comparison is easy. Second one is that original variable have different dimensions. I want to compare that 1 unit changes in reactant concentrant with 1 unit change in your other one, that amount of catalyst. So, as the units are different, so the meaning is different. Okay. Now, coded variables provide with orthogonal design. This is very, very important. This provides you orthogonal design, but which is may not be true for original design variables. So, orthogonality means what happened, that the dot product of two coded variables, the values if you consider, they will become 0. So, the independent part will be important here. We obtain different results while using coded or original design variables. Coded variables determine the relative size of factor effects. Relative size of factor effects. In the coded variable analysis, the magnitude of the model coefficient are directly comparable, and they measure the effect of changing each design factor over 1 unit interval, which is not possible, possible in original one. In the coded design variable, the model coefficient are estimated with the same precision. Standard error of the model estimate will be same, irrespective of what way it is measured in the original units. If you code it, and then each of the that regression estimates, they will be estimated with same precision. Standard error, same standard error. Original variables preserve the physical meaning of the variable. That is the main advantage of using original or engineering units, because they preserve the actual meaning of the variable, thus make the interpretation easier. But when you transform to coded variable, that is lost, it becomes dimensionless. So, you have to be careful while interpreting the results. Whatever may be the case, whatever may be the way we think, the coded variable is advantageous, and it is preferable in analyzing the experimental data, particularly in the 2 to the power k design, k factorial design situation, because you have already seen that even if you have the equation, regression equation or response surface in coded variable terms, it can be converted to original variables quite easily. So, now I will show you another example, that if you go for coded variable and keep original variable, how the regression estimates changes. Okay. Suppose that here we all know V equal to I R is the Ohm's law. V is the voltage, I is current, and R is resistance. And suppose a laboratory based experiments was conducted, and then keeping I in at two levels 4 amperes and 6 amperes, and resistance at two levels 1 and 2 ohms. So, then this is basically 2 to the power 2 design, and this is the basically design matrix for regression. And suppose that the response volts is replicated twice, then these are the responses obtained, and this is the total. So, what happened basically from here, I have shown you how this codification is done. This is now known to you. Now, with coded variable, and ultimately the regression equation is found out, and you see that the regression equation with coded variable is voltage equal to 7.5 plus this by 2 3.04. This is the equation. This is the equation. Now you can convert it to original variables also, fine, and you will get this is the equation. Fantastic. Now, actually what you do now, so what you are getting here, if you use coded variable, what you are getting here, not V equal to I R, what is the Ohm's law, what you are getting V equal to this plus this plus this plus this. So, here there is interaction term is there, but now if that means what will happen if this in order to preserve this law, that means this constant and other two these terms, this should be insignificant statistically, then we will not consider them, we will consider only interaction terms and we will get the results. Now, you see the output of the regression using coded variables, and you see this side, that means the constant is 7.5, x1 is 1.52, x2 is 2.52, everything all right, r square is very high and t values are very high. So, all the parameters are significant, that means the original, the main effect significant, interaction effect significant. Okay. Now, if you do the same thing in original units, what is happening here, you see only interaction effect is significant, but the other things including constant, they are insignificant. So, that means now what will happen after that, you do not consider the intercept and the main effect, only consider the interaction term and do the regression once more, you will find out that IR will be, this value will be almost 1. So, that means that is satisfying the physical law here, that physics law, but which is not done satisfying here. So, this type of issues will be there. So, when you basically analyze the experimental data using coded variable, you have to be very careful about the physical meaning of it. And another issue is that basically when there are such physics behind this, when something is known, so this also, that physics is to be taken into consideration, okay, while explaining the outputs, and this is true not for every models, not only related to the regression here. So, lecture as is prepared based on the book by Design Analysis of Experiment by Montgomery, and in fact we have prepared most of the lectures, almost all the from this book. Thank you very much.